So welcome to this session on visualization, which is, I guess, one of the most interesting and most fun things about R. Because even if you won't use R for any statistical analysis, one thing where it really shines is creating beautiful visualizations. There are a lot of tutorials in the internet. There's a lot of potential for using AI in this context. But I think it's important to get the fundamentals right. And this is what we're about to do in this session. So the goals for today is, first of all, want to focus on one particular package used for visualization in R, which is ggplot2. I guess it's probably the most widespread one. It's definitely extremely powerful. And I think you can really get most out of it if you understand the underlying theory. So if you understand how plots are created in a layer-wise manner using this package, and once you understand that and get the basics right, not only will you be very quick in delineating figures yourself, you will also benefit much more from using, for example, AI in generating some basic codes for visualizations and then tweak that yourself. We will learn most specifically about how you look at the variables in a data set and how to map them into visual aspects of a plot. I think this is where it gets interesting also from a theoretical viewpoint, or meta theory viewpoint, because it forces us to ask what kind of aspects in the data do we actually want to highlight or explore in our visualizations. And it's these kind of questions that we are forced to being asked when we think about visualizations, and that in themselves often help us to understand our data in a better way. And finally, I want to make some remarks on how you can reuse code across different visualization tasks, because this is, I think, also one very important aspect of the ggplot2 package. This makes it very easy for you to reuse code. And reusing code is always a good idea, because once something works, it's always a good idea to keep it for the future and save time and not delineating anything from scratch. So before we go into the technical details on how to create visualizations, I would like to tell you a little bit about the underlying basics and theory, and locate the task of visualization within the broader spectrum of data science tasks. This is the figure that we've been using so far. We are focusing on this part of visualization here in the beginning. As we said, visualization often takes place after a first processing and preparation of the data. Well, because the raw data you're downloading from the internet or that you get from your experience is often not in the shape that you can immediately use for visualization. And for ggplot2, it's important that the data is in a particular shape, and therefore you often need to do some data preparation and processing. At the same time, if you look at a visualization, it might indicate that a certain kind of aggregation of the data might be interesting. So you might get back to data processing after having your first visualization. Same thing with data analysis and modeling. It's a two-way relationship. On the one hand, visualizations are often used to basically represent the results of a data modeling or data analysis task. So it's about presenting the results. At the same time, it's also motivating further analysis. So you get the result of the model, you're visualizing it, and then you figure out, okay, hey, maybe I should have a look at this or that interaction effect. And then, of course, visualization is also part of presenting the overall insights of your data science story, so to speak. So visualization, really a key part of the whole data science pipeline. So about visualizations, I already indicated that. Visualizations can be used for many purposes, and I guess it's often underestimated, because often people say, okay, the hard task is to build good models, to do some quantitative analysis. And thereby they underestimate the power of exploring your data visually. So one thing here is exploratory data analysis. A visual exploration of your data is, especially in the beginning, often much more powerful as a quantitative analysis using a model. Because if you plot your data, you usually start to understand the patterns in your data. You understand what questions might be interesting to be asked in this context. and thereby they help you to come up with a good idea about a model in the first place, or to refine existing models based on the visualization of the preliminary results. Visualizations are actually key when you want to inform others about your results, because often you're talking to an audience that is not as does not have as much expert knowledge as you have. So you need to basically to address them in a specific manner, in a manner that allows them to understand your results without following on each step of delineating these results, steps that might involve very advanced knowledge about certain modeling techniques. And good visualizations are often very well suited to get the message of a certain model or its results right to the point, understandable for a wider audience. Visualizations are often used for manipulation. Others might try to convince you of a certain point by tweaking visualizations in a way that a certain interpretation leans itself to the viewer. I think manipulation is often not a very good thing to do. But I think you should definitely learn how to manipulate others with figures, not because you should do it in practice, but because that helps you recognize the strategy of others. If you know how you can create a data set that manipulates others to see this or that in the data, you are much better prepared to spot these kinds of attempts by others. And believe me, I think media, social media especially, is full of these kinds of manipulation attempts. So I wouldn't like to see you manipulating others, but I think you should know how to do it just in order to defend yourself against manipulation attempts that you definitely will be confronted with. So all these kind of things you can do with this package, ggplot2. You can also use different packages, but I think this one is very good to do so. It's very easy to, the code is easy to read. It is very widely used. I think it's very powerful. You can do a lot of stuff with it. You have very, very good educational materials. So I think in general, it's a very good baseline tool to use. And I know from many people who actually work more with other programming languages, but when it comes to visualization, they also use R simply because of ggplot2. And there are a lot of extensions that allow you to do basically everything. You can do animated GIFs, control charts, and much, much more. So I think it's really a good investment to do that. But what you always need to do is to take a step back from the technical issues, but ask yourself, okay, what do you want to show in the first place? If you ask yourself, okay, what do I actually want to show? This is one of the figures or the pictures I really like, because it gives you a structural attempt where you're first being asked, do you want to compare certain data points? Do you want to visualize the distribution? Do you better want to understand the composition of certain groups in your data? Do you want a static or a dynamic view on the data, etc., etc.? This is the way you should think about these, about the decision of what kind of plot you actually want to create. So I think it's very important that you don't start right from the beginning, okay, I definitely want to create a line chart, but you need to ask yourself, okay, in my data, what is actually my interest? What do I want to understand? Or what I'm curious about? Am I curious about the distribution of a certain variable? Am I more curious about the relationship? And then really try out different alternatives. Yeah. This also shows that visualization always involves prior thinking and theory. It's nothing that you can do fully inductively. There is always a thinking process, and you should be explicit about that. You should acknowledge that. It's not a drawback. Be explicit about it as much as possible. And once you've figured out which kind of visualization you want, this is also not a decision for eternity, because a cool thing about ggplot2 is that the syntax is very similar for all of these different graphs. So it's not that you need to learn how to create each of these single graphs from scratch. You need to understand the basics of ggplot2, and then often the change from a line chart to a bubble chart or a scatter plot. This difference in the code is not that severe. That makes it actually quite easy to learn. In this lecture, I want to focus on two examples, a scatter or bubble chart that I mentioned earlier, and a line chart. And there I want to focus a little bit more on the scatter plot, and then use the line chart to illustrate how easy it is to adapt your code to create a figure that looks very differently, but that actually shares a lot of code, which is nice because you can reuse a lot of stuff. In practice, when you don't exactly know which kind of the figures you want to build, how to create that, you really should go into the internet and look for blueprints. So this is a page that I like very much. It has a similar decision tree in it, like the one in this figure here. And it has a lot of good code examples. So you can have a look at the pictures, look at code examples, and you have blog posts on the pros and cons for the different figures. I learned about many new figures by actually reading these short blog posts. And this is something I would really recommend you to do. Also because it's quite easy and it's also very fun. So the creators did a very good job in making this material very, very accessible. What I would like to do right now is to start with a very, very simple example in the beginning so that you have an initial idea about how the code of ggplot2 looks like. And then later we go a little bit more into the logic of ggplot with its layered approach of creating figures by going through one example step by step. But before we want to do this, I just want to give a very quick preview about how the code for these figures looks like. So here you see a very simple scatter plot with two variables plotted on the x and y axis respectively, and a third variable basically plotted on the color aesthetic, where we see that the dots have different colors, and this represents one variable in the data set. This is how the code looks like to create this figure. Not very long. It's also because it's very, very simple figure. And the first line is actually just to get the data set right. So this is something very specific for this example. I used this data set from the data science exercises package, and I just created the association with a GDP data name in order to have a nice shortcut. This is how this data set looks like. It has four variables in the four different has five variables actually: the different country, the continent, life expectancy, population, and GDP per capita. And the task of the ggplot2 plot is always to basically link the variables of the data set to visual properties of the figure. Here we have some general metadata about the plot. This is basically everything that is in the initial ggplot call. So we have the function ggplot, and this function contains basically metadata for the plot that all other upcoming functions will use as a default option. So what we have here, for example, is the specification of the underlying data set. So with the argument data equals GDP data, we basically tell ggplot that for everything that comes later, by default, refer to this data set. You can also use a different data set, but that you would need to make explicit. If a function is not given a different data set, this is the default option the function call is about to use. The second argument is the mapping argument, and the mapping argument basically tells ggplot again per default which variables to map to which properties of the plot. So in this case, for example, we have the x-axis, the static, the x-axis, and the x-axis should be associated with the variable GDP per capita. So you see it from the data set, the variable GDP per cap is mapped basically on the x-axis of the plot. Similarly, the y-axis is the variable life expectancy. So from these two variables, x and y, we have geometric precision for each point that we then later see in the plot. But so far, this only refers to x and y axis. There's nothing about points so far. The third default association we have is the color. So we want to color points according to the continent that is given in the data. And now comes the point of time where we actually draw the points on the plot. So we have set the default options using the ggplot function, and now you see the plus sign at the end of the function. That means, okay, we now want to add an additional layer to our plot, and this additional layer should contain points. And the position of these points is determined by the X and Y aesthetic that we have clarified before. And the color of these points is specified by the aesthetic mapping that we have defined for the color argument. So the points are colored according to the value of the variable continent in the underlying data. As I said, everything you write in the ggplot function is used as a default value. So in geom_point, you could specify a different data set or a different mapping for color to override what is written in the standard ggplot function called before. But if you don't write anything or do not provide anything as an argument for this function, the default options for the ggplot function before are used. That's useful because often you want to combine points with other aesthetics. But for this example, we don't do anything more other than using a general theme. A general theme controls many visual properties of the plot at all, and this theme classic makes the plot look very clean and simple. And this example already shows you a little bit the underlying logic of ggplot. Yeah, to start with the function ggplot, to define the underlying data, to define the mappings, and then add layer-wise certain geometric forms to the plot. There's much more you can do. I mean, this plot is far from perfect. There are many things you can change, but I wanted to have it as a general example of how this looks like. And this brings us to the practical workflow. Here is a little bit an idea of where we actually want to go. So today we want to get started with visualizations, and the goal at the end of the session is to be able to produce the following two plots. On the one hand, this is a little bit an extended version of the plot that I just showed you about the relationship between life expectancy in years and GDP per capita in international dollars. This plot has basically everything you need for a publication-ready plot, included a small note, explanatory note in the bottom right, and reference to the data. And the second plot that we want to build is this line graph here. And an important reason for building this line graph is to show you how similar the code of these actually very different plots is. So you can reuse a lot of the code you've written for the left figure in order to create the right figure. So the mechanics to create these plots is very, 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 very simple. And if you have a look at the readings that I suggested, you will be able to make a lot plots already from the beginning. Okay, what's the general idea of creating plots in ggplot2? So this is, I think, is very important to understand. Every plot in ggplot2 is generated in two major steps. The first step is basically to describe the plot in all its details via a certain list. And then secondly, you basically call this list and only then R renders the plot for you. This is important to keep in mind. Why? Because the first step, this is actually where all the work gets done. Now, this is where you spend most of the time actually when creating the plot. Second step is, that's basically just a call of the list. But this is the step where all the errors become apparent. So you can describe the plot in a very, very inconsistent way. You don't get any errors most of the time. But when you then ask R to render the plot based on the description in the list, then it's where you get the error. This is important to keep in mind because sometimes people make very extensive descriptions. They're very happy, and then it becomes very difficult to actually track the source of the error. That means you should start very simple, render the plot, then see what you want to change, re-render it, make the change. This way you identify the source of potential errors very, very quickly. To create this list-like description of the plot, you don't need to create that basically yourself. You can use all the helper functions that plot2 provides to you. And the idea is always to start with an empty plot with nothing on it, and then add layers above this empty plot. Then finally adjust some details, and then that's it. Yeah? And what I would like to do is to illustrate this using a subset of the very famous Gapminder data set that only contains data for the year 2017. It is made available through this package data science exercise. And throughout the next videos, we would create this plot on the left side that you just saw on the previous page step by step. And when doing so, we will illustrate this general idea that you start by describing the plot in the list, then you call the list to render the plot, and that you extend the description of the list by basically laying one layer above the other to finally get the figure you initially wanted.